Okay, in this review video, we're going to start with figuring out the discriminant. So remember that the discriminant is part of the quadratic formula that predicts the number and types of solutions. So that is b squared minus 4 times a times c. So our b is 3, so I'm going to have 3 squared minus 4 times a, which is 3, times c, which is a negative 6. I'm going to take and type that into my calculator. Remember, we've talked about the importance before of putting parentheses around. And when I do, I'm going to get that this is a discriminant of 81. So that is the discriminant number. If I'm asked what that discriminant number tells me, it tells me that there is going to be 2 real solutions, that I either need to continue solving this by factoring or quadratic formula and find out where those intercepts are. All right, let's look at the next problem. If I'm looking for the discriminant here, my a is 3, my b is 0, the constant is 4. So I've got to make sure that I understand the a, b, and c correctly. And now when I go to do the discriminant, b squared minus 4 times a times c, I'm going to have 0 squared minus 4 times a is 3 times c, times c, which is 4. And what's going to happen is that's going to give us a negative 48. A negative discriminant tells us that there is no real solution to this quadratic function. If we look at the next problem, we are given the intercepts at negative 3, 0, and 2, 0, and we're asked to do 2 things: write in factored form and then write in standard form. So we go to write in factored form. Remember that if our factor is negative, or if our intercept is negative 3, then our factor would be x plus 3. And if our intercept is at 2, then our factor would be x minus 2. So that is our factored form. If we go to take that factored form and move it into standard form, what I'm going to need to do is multiply this binomial times a binomial. So you can do that either using distributive property twice or using the box method, your call. I'm doing distributive property here. And if we combine our like terms, this will give us our standard form. So here's our standard form. And here is our factored form. Our next problem, we're going to look for the vertex and the axis of symmetry. Some of you might like to find the intercepts and use that to find the vertex. But if we look at this problem, x squared plus 4x plus 10, if we look for 2 numbers that multiply to 10 that add to 4, we're not going to be able to come up with that. So this is one that we're going to have to use this formula to figure out the x coordinate of the vertex. So my b is 4, the opposite of b is negative 4, divided by 2 times 1, because that's 2 times a. And so that's going to give me that the x coordinate of the vertex is negative 2. I also know that the axis of symmetry then is the vertical line x equals negative 2. Now I'm going to go back into my original equation, and every place that I see a negative or an x, I'm going to substitute in negative 2. And then I'm just going to calculate the y-coordinate of my intercept. So let's see, this would be a negative 2 squared, positive 4, minus 8, plus 10. Or you can just put this on your calculator if you prefer. The y-coordinate is going to be 6. This one here you have a choice with. If you know that this is factored form, we could then very easily say if this is one of our factors, we have an intercept at negative 4 and we have an intercept at -6. If we take those two intercepts, add them together, and divide by 2, that gives us the x-coordinate of the vertex and also the axis of symmetry. And then to find the y-coordinate of the vertex, we would go back to the original problem, and where we see that x, we would substitute in -5. And so I would have -5 plus 4, that's a -1. -5 plus 6, that's a +1. And that tells me the y-coordinate of the vertex is -1. The alternative to that is you could take this that was given to you in factored form, and you could actually multiply it so that it would be in standard form. Once it's in standard form, you could see x is equal to the opposite of b divided by 2a. You would see that you would still get -5 for the x-coordinate of the vertex. And we've talked before about finding the y-coordinate of the vertex. You can either go back to the original equation up here and put in -5, or what you have multiplied to put into standard form, you could put -5 in here also for x, and you would still get the same y value.